right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is a worksheet on discrete exponential growth and decay. That's a mouthful. But let's look at what the problems are. How do we solve them? How do we use the graph to help us solve them? Do we need to use the graph? Do we not need to use the graph? All that kind of stuff and more. Let's jump in to this worksheet that's from Kuta software, Infinite Algebra 1. So the directions specifically say to solve each discrete exponential growth decay problem. By the way, discrete doesn't mean what it normally means, like in real life, being discreet about something, like keeping a secret or whatever. It doesn't mean that. Discrete in math, the simplest way I can think of to describe discrete was points rather than a line or a curve. It's like points or small pieces or whatever, instead of like a line or a curve, like one thing instead of one thing. It's like multiple things, a little points or segments or whatever. And exponential, so it's going to skyrocket. Right, so it's going to skyrocket, either skyrocket up if it's growth, or skyrocket down, or sorry, level out if it's decaying. And that's what that first sentence is. Then it says you may use the provided graph to plot points or sketch the exponential function. So you don't have to, but you can. I think I probably will use the graph, but we'll maybe solve the graph first and then, or solve the problem first and then the graph, and then maybe do vice versa, and then kind of just decide on which one we like better, I guess. There's only 4 questions, so this isn't going to take too long here. There's one formula we need for all of these kinds of questions, and that formula, you might use different letters. You might use, totally different letters, but the letters I'm going to use are the ones that, to my knowledge, are used the most. And that's A equals P 1 plus R over N to the NT. Okay, so this is what's called compounding growth or decay formula. It's really used mostly for money, when you have money that's compounding and you want to figure out how much money you're going to have in a certain amount of years, assuming an average rate of return and whatever amount of times in a year you're compounding it. So that's typically what this formula is used for. You can use it for other things, though. For instance, with number 1, an employee receives a 2% raise. Oh, by the way, A is the ending amount. So we're going to say A for amount. Let's define what all these letters mean. So A for amount. That's like the answer, right? So A could also be for the answer. It isn't always the answer, because sometimes you're not solving for whatever the future value is. Sometimes you know what the future value is and you're solving for the initial, blah, 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 blah. There's so many different things, but that's the amount, or we should say maybe the final amount, right? So the final amount, okay, versus the initial amount. So P actually stands for principal, which is a little bit of an older word, but it just means the first amount, right? So the final versus the first. All right, the first amount versus the final amount. Okay. So then the other numbers are for rate, and we want to write that as a decimal. So when they give us a percent, we need to change it to a decimal. N is the number of times compounded in a year. Number of times compounded. And this is normally in a year if you're talking about money. It doesn't have to be. It's basically whatever T is. So N actually depends on T. So T for time, which is normally in years, but if T was actually in months, then N would be the number of times that you compound in a month. So N depends on T a little bit. N is the number of times you compound in whatever the unit for time is. Normally time is in years, so N is the number of times compounded in a year, but it doesn't have to be, which actually, spoiler, that's going to be one of the questions that we do on this worksheet. But there's all the different letters and what they mean. So let's you know what? Because I have so much going on here for number 1, let's just go ahead and graph it and just start with that, right? So if the employee's initial salary, right, so in year 0, in year 0, if the initial salary is 60,000, that's going to be right here. Right there. Bada bing, bada boom. So the initial salary is 60,000. What will the employee's salary be after 9 years? Okay, well, it's going to go up 2% once per year. So we would take 60,000 and multiply. So that this is the shortcut way. If you wanted to do a shortcut way, wait, why am I using my phone? I have a graphing calculator right here. There we go. So if you wanted to do, like, let's say, I don't know, just kind of wing it, then it's like, okay, well, 2%, right? What's 2%? It's 0.02, right? So 0.02 of 60,000, $1,200. That's a $1,200 raise in a year. 2% is actually not that much. It's actually not even keeping up with inflation, so you should actually have more than a 2% raise every year. Just saying. But what we want to do is we actually want to either add that back to the 60,000, and you guys can't see what I'm doing on my calculator, but that's what I'm doing. I'm adding it back, and I'd get 61,000. There we go, I can read. 61,200 because I have a $1,200 raise, so I have 61,200. 61,000. All right, well, this is like a $10,000 difference here. So it's really not that much of a raise. If you're looking at the graph, it's really not coming up by that much. But it's going to go up by 2% every year. So if we wanted to know what it's going to be the next year, we would take our 61,200 number and raise that by 2%. It's not 2%. It's not a 2% raise every year based on what you had initially. That wouldn't even be exponential growth. 2% raise based on whatever that year's salary is. So it's 2% on top of 2% on top of 2% on top. So that's actually pretty good. It's better than, just adding a little bit each year, because, then you wouldn't even be going up by an exponential amount. So what we could do instead of multiplying by 0.02 and then adding it back to the original is just times it by 1.02. So we take 61,200 times it by 1.02, the 1 being, well, that we're multiplying it by itself, and then the 0.02 that we're going up by 2%. So 61,200, which is how much you make in the, after a year, times 1.02, and I get 62,424. 62,424, so it looks something like that. And then you can just keep going until you get to 9, right? So you can just keep going. You can just keep multiplying by 1.02 times 1.02. Now I'm at 63.6, so almost 64. We're almost halfway now. Almost halfway. Okay, times it by 1.02 again. And if you already know how to do this with the formula, you're probably like, just get to the formula. I will. I just want to show you where the formula comes from. And I already wrote out the formula, so calm down. Times 1.02, 66,000. We're just inching along here. Times it by 1.02 again. 67.5. So now we're getting like 3/4 of the way, basically. So about right there. Times 1.02. Notice it doesn't really look like we're going up by that much, but we are exponentially increasing. Eventually, we would start to skyrocket. 68,900. So we're like really close now. We're getting really close to 70,000. Times 1.02. We broke into the 70,000 range. Okay. Just over 70,000. Times 1.02. 71.7. So about 72. About 72, about right there. So it is starting to go up by a little bit more each time. Now, if we kept going, eventually it would start to skyrocket. Eventually it would, because this is exponential growth, it would eventually skyrocket. And so that's cool. That's good. Now, I did this the long way. Went all the way up to 9. So it says, what will the employee salary be after 9 years? So year 0, right? And then you count all the way to 9. And I got 71. And we want probably, if we're talking about money, right? If we're talking about money, then we probably want, I'm going to zoom in a little. Can I zoom without? Oh, I can. Okay. So if we're talking about money, then we probably want to write it in terms of money in dollars and cents. Round to the nearest cent, aka 2 decimal places. So that is how much money you would make in 9 years. You would be over 10,000 more than where you started within 10 years. It sounds good when you say it like that. And because I said I was going to do this, let's go ahead and type it into the formula as well. So A is equal to P, the principal, 60,000. Lots of zeros. 1 plus the rate is 0.02. Divided by n, the number of times compounded in a year. We are compounding once in a year. To the n, again, times t, 9. And that is how you do it. We can clean it up a little bit before you put it in the calculator, or if you feel pretty confident in your calculator typing in skills, then you could just do it that way. So this is going to be equal to 60,000. I'm going to clean it up just a little bit first. You don't have to. You could just type it in, but this would be 1.02 to the 9 power, and I think that's a little easier to type in maybe. So 60,000 times 1.02, caret key, 9, enter. I'm using a TI-84 Plus. So it's an older graphing calculator, but it still works. And then look at that, I get the same answer, right? So I get the same answer because I'm doing the same thing. I ended up doing the same thing. Now, what I did was I first multiplied by 0.02. I took the 60,000 and I multiplied it by 0.02, and then I added it back to itself. But that's the same thing as multiplying by 1.02. So all I really did to do it the long way was just multiply 60,000 by 1.02, and I did that 9 times, and then I got the answer. Well, that's exactly what this formula is doing. I'm taking 1.02 to the 9th power, aka timesing 1.02 9 times. There's 9 of them being timesed up. And then there's also that 60,000. Okay? So that is how you do it. Starting with the graph and then going to the actual thing. Let's just start with, I'm going to kind of skip to number 3, I think, and then I'm going to kind of zoom and move number 2 over. And I think that's what I'll do with this. And yeah, I think that's my plan. Yeah. So let's move on to number 3. Since I don't really have to do anything to get to number 3, I just kind of scroll down a little bit because I know my picture or myself or whatever way down there in the bottom right is kind of hanging out there, blocking the way a little bit. Let's look at number 3. A robot vacuum. DJ Roomba, anybody? Cleans a dirty floor using multiple passes, meaning like, it's it hits the wall and then it turns around and moves back the other way or whatever. If you've ever had one, it's you know exactly what I'm talking about. During each pass, meaning like, the straight line distance or whatever, 22% of the dirt is removed. They should say on average, because if you've ever seen a Roomba, it's like it never travels like the same distance before it hits something. It's like always a different distance each time. 22% of the dirt is removed. Wow. That's actually a lot. 22%. Like, either this is a really small room or this is a very good Roomba. Like it's got like motion detecting or something. Like it goes around all obstacles as it cleans or something. But anyway, so 22% of the dirt is removed during each pass. If the floor is initially 530 milliliters of dirt, it sounds like a lot, but that's half a liter. But that's spaced out across an entire floor. And we don't know how big the floor is either. Not that we need to, but I don't know. How much dirt will remain after 10 passes? Okay. So this one is a little, we're going to use the same formula. A equals P, 1 plus R over N to the NT. Now, this is for money. This is a money formula. It's what it's really meant for. All the letters mean stuff with money usually. But like I said before, you can use this formula on everything. Really, really. You can use it on everything because it works on everything, because everything is, if it's exponential, if it's a percent increase or decrease or whatever, then this is the formula. So 22% of is removed. The floor initially has 530, so 530 is the initial amount. 1 plus the rate, so 22% of the dirt is removed. is removed, that's a negative. It is going away, right? So if I put 22%, 0.22 as the decimal, if I put it as a positive, then it's going to increase, right? If you put a positive rate, it's going to increase. It's going to be exponential increase. We don't want to increase the amount of dirt in our house. We want to decrease it, right? That's what the vacuum cleaner is doing. It's decreasing it. Dirt is removed. So be really careful. Make sure your answer makes sense. It's 0.22, but it's negative 0.22. Okay. Over n, which I'm going to leave blank for right now, to the n times t power. Okay, so t is normally time, right? T for time. Start with the same letter, but t is not time. Not here, not on this particular problem. I mean, it's basically still related to time, kind of, but we don't know how much time it takes to do a pass. And I don't think they do either, because this person who made this problem has never had a DJ, Roomba. So, Anyways, 10 passes. All right, so time is not time. Like, t is not time. It's passes. It's the amount of passes that we do. Not just time. So the n is normally the amount of times it's compounded in a year, but now it's the amount of times it's compounded in a pass. Well, it's saying each pass there's something happening, right? So during each pass, 22% of the dirt is removed, as in, once the robot vacuum does a pass, 22% of the dirt is removed. We don't know what the rate is that it's removing the dirt at, which actually that would be like a static number, basically. But this is saying that we only know that once it's done a pass, 22% of the dirt is removed. So n then is the number of times compounded in a pass, which is just 1. So it's just 1 still. And then we want to know how many times, what's happening after 10 passes, right? So t is 10 for 10 passes. Whew. Okay, so then we got everything plugged in. So now I go here, 530. That's going to be 1 minus 0.22. So 1 minus 0.22 is actually going to be 0.78, which makes sense because if you have a decimal that's less than 1, between 0 and 1, then it's going to go down, actually. If you have a exponential function and your base number is between 0 and 1, that is decay. Because if you were to write that as a fraction, it would be a fraction between 0 and 1. What happens when you have numbers that are less than 1, in between 0 and 1, they go down, because when you multiply a number by itself that's in between 0 and 1, you're finding a fraction, not a whole number. You're finding a small fraction of the original. Well, if you're finding a fraction of a fraction of a fraction, then it just keeps getting smaller and smaller. So that's it. We've got it all set up, and then we can just type it in and get the answer. So 530. And I just realized I think I forgot to, oh no I didn't. I was going to say I forgot to put the graph for number 2, but I didn't even do number 2. I'm skipping number 2 for right now. Come back to it later. Okay, so 530 times 0.78 to the 10th power, and I get 44-ish. And it says, the floor initially has 530.0 milliliters of dirt. How much dirt will remain after 10 passes? We want to know how much dirt is remaining. It doesn't say to what decimal place to round to. 530.0, though, has 4 sig figs, because it's 0.0. But 10 passes is a 1 significant figure. 22%, that's 2 significant figures. So we have 2 sig figs, 4 sig figs, 1 sig fig. I don't know. Maybe we'll just stick with 2. We'll just stick with 2 significant, two decimal places. We'll do 2 decimal places. That's pretty standard for math. So 44.18. 44.18. So area, or the answer, 44.18. And that's milliliters. So 44.18 milliliters. And so I'm doing 2 decimal places because that's pretty standard for math. If you guys need to do a different amount of decimal places, then, go for it and do a different amount of decimal places. But, I'm going to do 2. If you guys need to do more or less or whatever, you do what you got to do. So that was that was it for the left-hand side column. So actually now I'm going to move over to the right-hand side column. I'm going to try to move this over here if I can. It looks kind of weird, but let's see if I can kind of move that out. I can if I go like that. So I can't actually see my camera. I have it like off to the bottom right-hand side, I know, but I can't like see it as I'm working. I only know where it is when I've got like, my software thing up. But anyways, we'll just pretend like it's not blocking anything. I don't think it is. Let me know if I've been blocking something, because I'm probably not going to edit this. I'm probably just going to put this out just as is, because that's what I normally do. Let me know in the comments if you think I should be editing my videos. give me some feedback there. A new social media site is increasing its user base by approximately 6% per month. That's good. I mean, that's exponential growth. So, hey, go for it. If the site currently has 21,740 users, which is not that many, not for like, a social media giant, like Facebook or Instagram or whatever. What will the approximate user base be 8 months from now? Okay, so we want to know it's 6% per month, which, if you're compounding in a year, that would be 12 times compounded in a year, but t is in months. So we're still compounding once. So we're still just going to use the once formula. And by the way, let me show you another formula. And this is an easier formula, so don't worry. So let me copy down the first formula again, r over n to the nt power, right? So that's the basic formula. I didn't realize this, because when I looked at number 2, I was like, oh, we will be compounding a different number of times than just once for n. But then I didn't actually read all of number 2 until just now. Time is in months. So we're still compounding once in a month, because t is in months. So area, or sorry, I keep saying area, the answer, or the amount, the final amount, if you wanted to do compounding once, a compounding once formula, then n would actually just go away, because it's r over 1, which is r. And then n is 1. 1 times anything is that number. So if you want another formula, this formula is a little easier. This is the formula for if you're compounding once. If one thing is happening at a time, that's the formula you might use. Oh, I did forget to graph number 3. I think for time reasons, I'm just not gonna graph the rest of them. I'll show you what the graph looks like at the end, because they have the answers at the bottom. But so that would be the formula you would use if you wanted to compound once, and that is what we want to do. What will the approximate user base be? So we still want to know the final amount. The initial amount is 21,740. 1 plus the rate, right? So 1 plus the rate. The rate is 6%, so 0.06. We're increasing, so it's plus 0.06, not minus 1.06, or 0.06, to the t power. Okay, so t is in months, so we're just going to put 8 here. We want to know what's happening 8 months from now. You could make t years, but that would make the formula way more complicated and unnecessarily complicated. So we're just going to not do that. And as always, I'd like to clean this up before I plug it in. So area, I keep saying area, it's not area. It's the answer, the ending amount, 1.06 to the 8 power. Okay, so I'm going to type that in now. 21,740, excuse me. That's like a double hiccup there. 1.06 to the 8 power. And I get 3, 4. I'm not very good with my working memory here, so I'm going to just keep this right next to me. So the approximate amount, well, squiggly there, 34,000. And these are people, right? So we would round to the nearest whole number, actually, because, you can't have a fraction of a person. So the context of the answer matters. That's why I was trying to figure out how many decimal places we might use for number 3, because I was like, I don't know, because you can have a decimal amount of milliliters. I mean, that's totally possible. And there's no limit to how many decimal places you might do for milliliters. So I don't know. But for people, you can't have a fraction of a person. That would be rude. People are people. Just making sure I have the right number there. All right, so that is it. So that would be our number of people, our number of users, which are people. Hopefully they're all people. There's always some bots or whatever. If you've been watching the news lately as of November of 2022. You've been probably hearing about Musk buying Twitter and talking about how there's like bots and stuff and not wanting to buy it because there's bots and all that kind of stuff. I don't know. I don't really keep up with news too much, but you know that is possible. Have some bots in there, some fake users. Okay. Anyways, a country pledges to reduce its annual CO2 emissions by 3% per year. Reduce, right? So it's going down, going down. 3% per year if the emissions in 2022 are 3,030 MT, metric megatons. Yikes. What are the maximum allowable emissions in the year 2028? This is actually fairly relevant because a lot of countries have signed agreements to reduce their emissions to a certain amount by a certain time, by a certain date or whatever. So that would be helpful for the countries who pledge to reduce their emissions to know, so that way they can track their numbers. If they're going to say they're going to do something, back it up. But we use the same formula still. Same formula. Just gets reduced, reused, and recycled. So 1 plus, I'm going to use R, I think, because this is per year. And we're talking about years, right? So time is in years, and we're compounding once in a year. So we don't need the other formula. We don't need an N. N is 1. So it's just 1 plus R to the T power. That's the formula we'll use. Okay, so A, the answer, the ending amount, is equal to the principal amount, the initial amount, 3,030. I don't need to worry about the units because we're going to keep the units the same, because in the chart they even say that, you know, we're keeping the units the same. So 3,030 is the starting amount. 1 plus the rate. Oh, sorry, 1 minus the rate. 1 plus a negative rate would be another way to write it. Oh, I thought I hit the erase button. I did now. Minus, you could put plus and negative, but I'm going to do a minus. 0.03, 3% is 0.03. Time. Okay, so time is not 2028. It hasn't been 2028 years since since this country has started doing their emissions. Be really careful, right? Don't just blindly plug in numbers that you see, okay? 2028 does not make sense to plug in for T. It has not been 2028 years since this country made that pledge, right? 3% per year for reducing by 3% per year for 2,000 years. You'd basically be like zero net emissions by then, because that's a lot of years. So so that's not what's happening, right? So we want to figure out how many years it's been, right? So if the emissions in 2022 are 3,030, then in 2023 there's been 1 year that's passed, right? 1 year has passed in 2023, aka 2023 minus 2022 is 1, so 1 year has passed. So all we have to do then is just subtract the 2 years. 2028 minus 2022 is 6. 6 years have passed, so T is 6. And so then I like to clean it up a little bit before I plug it in. And if you can't see this just yet, I apologize. I will scroll down in a second. 1 minus 0.03 is going to be 0.97. So 0.97 and then to the 6th power. Okay, so let's go ahead and type that in. You definitely need a calculator for this. If you're a teacher, make sure you do this by hand. Then they are torturing you guys. That's like a reportable offense. Definitely need a calculator for this stuff. So our emissions go down to approximately, and do they say how many, what approximate emissions we want to go to here? They don't. They don't recommend. They don't say what the units are. Okay. Well, we'll just assume 2, since this problem doesn't really lend itself to any particular number of units. So we'll just go with 2 decimal places and just call it a day there. So 0.91. All right. And the same units, right? So megatons or whatever it was. Was it? It was metric megatons. There we go. So megatons. All right. And that is the answer. If your teacher is a little bit of a stickler about units, make sure you're putting the units in there. I did not include units. But if your teacher wants you to do units, then do units. Like, don't be like, oh, some random guy on the internet told me that I didn't have to use units. Like, I don't think you do. But if your teacher does, then you should do that, because they're the one giving you a grade, not me. So definitely do that. Put those units in there and get the full credit, right? Just do it. Just do it. So that is the answer for that one. I think we've done all of them. Let's go ahead and look at the answers. They have the graphs over here too as well. Here's number 2, I believe. All right, so social media, blah, blah, blah. There's that graph. They have an arrow on the left-hand side as well, which I think doesn't really make any sense because who's going to go less than 0, right? Less than 0 months? That doesn't make any sense. So that should not be an arrow. They got 34,650. Good job. And then over here, I don't know why they do this. There wouldn't be an arrow on that side. There would just be a dot. It's going down to 2524. I think I said 2524, right? Yeah, 2523.9. Yeah, so they rounded to the nearest whole number. Did they say at the beginning whether to round to the nearest thing or whatnot? It did not. Okay, so it's just, whatever you need to do, I guess, to get the right answer, right? So, yeah, if this has been helpful, of course, do the thing, like, subscribe, comment, blah, 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 all that good stuff. But I've also got other videos like this on the channel, so go check out those videos. And if you want to get other stuff that's not on YouTube, I'm working on building out a website that has a bunch of stuff on it. So I'll have it have like textbook kind of stuff, like general guides, like quick notes, like Spark notes on a certain topic or whatever, that kind of stuff. It'll have all of these kind of worksheets on it as well. So it'll have, all of this kind of stuff on it. These worksheets that I've been doing and the answers and all the work for them and everything. Those will be on there as well. So if you need to just see some of the work for a worksheet, if you want to do that, save a little time or something, you can do that. That should be on my website as well. Go check that out, myersmathematics.com. Link in the description below. And when you first go there, there's a free guide that I created. It's a little PDF guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. So go check that out. I made a little free guide. You can grab that and check it out. And let me know what you think about it after you read it. I think I might have like some sort of like raffle or something for that, because I really want some feedback so that I can continue to make everything better. So let me know if that's something that you would be interested in. If you want to win some free stuff, let me know in the comments below. But anyways, have a good one, and I'll see you in another video real soon.